So I want to thank Taylor again, Tejas, and also Oracle for me to be here. Now, what I would like to do is give you an idea of what kind of solutions are built on Oracle and how our customers use those solutions and why would they want to use these solutions, and also give you some idea of how Oracle kind of differentiates from other cloud providers. The first thing is, what is d3View? So d3View is a web-based platform. D3 actually stands for data-driven decisions. And we actually enable that through visualizations. It's a web platform. Anybody could just, with a web browser, can connect to it. Now, as a data-to-decision platform, we excel in data extraction. So for example, as somebody mentioned, there's tons of data produced by virtual simulations, and we excel in extracting information from that data. So we take 10 terabytes of data sets. We could do all kinds of things like compression and transfer speed and so on, but we said, why don't we extract the information on the cloud? So we reduce all of that data transfer and provide that intelligence to the user. So we do that data extraction very well. Now, once we do that, we can do that for multiple simulations. So there's kind of standardization. So that means naturally we can visualize them in a very unified way. So we provide lots of visualizations for that. One of the key aspects is, of course, you need an HPC system. So we integrate very tightly with HPC systems, both on-prem and cloud. And with that regards, OCI provides us tremendous APIs so we can communicate, start instances, stop instances very quickly. Now, we talk quite a bit about simulations, but if you see in the industry, there's quite a bit of overlap between simulations and experimental data. I'm sure you heard digital twin, where everything is moving to a digital platform. What we see is a tremendous amount of validation, or the verification is also being done in experimental labs. So what our customers want is they want a system that can understand simulation data, but they also want to know, how can I bring my data from the labs and overlay them to see how well am I doing? So our platform enables both simulations and experimental data. Now, our customers have a lot of systems, and those systems are done by subject matter experts. Let's take an example of a site impact specialist. You give him a car, and you tell him this rating is about 2.5 and 3, and I want to make that to a 5-star rating car. Now, he has certain process that he follows to achieve that, maybe in a month, maybe 3 months, and so on. What if that person switches groups? What if he moves from one company to the other? Now, that intelligence is captured today in our system using workflows. And so what we've done is we've captured all of these processes, and we can execute those workflows by any other engineer within the same company. And that includes computing, extraction, comparison, and so on. The other thing that we have is an analytical platform. So we could do regression analysis, we could do k-means, we could do clustering. So we do quite a bit of analytics, and we provide those with a bunch of visualizations. Now, in our industry, we not only gather information from the data, but we do quite a bit of transformations. We do integrate, differentiate, do Fourier transform, and so on. So we build our platform with all those math operations that's available to them. Finally, I'll talk a little bit about machine learning and artificial intelligence. I'll give an example of airbag manufacturer, Takata. They run DOE with about 500 simulations per set. Now, how do you determine if a bag deployed at the right time to protect the occupant? You have to run through all those 500 data sets and look at the image one after the other to decide, okay, this bag deploys correctly. And that's where we use TensorFlow, we use the artificial intelligence. We train the system with a neural network, and we classify them as deployed or undeployed, and so on. Now, when we talk about a platform, we need to have a system that can accommodate many different applications. This slide just gives you an idea of what kind of applications we have. We have templates, we have simulations. I want to point you out to a few critical ones, and that is the workflows. Yeah.
We're having trouble hearing you on this side.
Okay.
So if you want to use the mic, that's
sure. So this slide will just give you an idea of the different applications. I'll kind of draw your attention to a few critical ones. The Simlytics is the rich interactive visualization you can think about as a Tableau for simulations. We also have responses right next to Simlytics. That's responsible for gathering all the information from any different data. We understand most of simulation data. We also understand data from experimental labs, so we can just grab information from them. This should give you a typical workflow for an end user. What you have is, think about an engineer, a simulation engineer on a workstation. He's going to submit a simulation to d3View, and d3View is responsible to communicate that information to either on-prem or on the cloud. And we talk through APIs and we run those simulations. Now, that's the easiest part. Once the simulation completes, we then go into work by extracting the information. So what you see at the bottom is the information that the user wants to see. And these are images, these are curves, these are charts. And we do that through a pair of Simlytics and Simlyzer that grabs the data, extracts everything in the cloud, by the way, everything on the on-prem hardware. And what gets sent to the user are just these images and curves, which is less than 50 or 100 MB of data. What we also specialize in the scientific data. What you're seeing is just some snapshots of curves, images, and movies. And these are all in-browser capabilities. They can overlay them, they can highlight them. And this is really what helps them reduce to bring all of that data from the simulation onto their workstation. This is a short movie just to show you how we enable them to look at the image once they achieve them. So once you're on a workstation, you can look at them, you can compare them, you can look at the differences between two different simulations that you ran, and you can quickly identify small differences to determine the impact of your input. Now, when you talk about simulations, you naturally have to deal with 3D data. Here we have an in-browser, GPU-powered 3D visualization platform that brings, let's say, a gigabyte of data, converts it to less than 100 MB of data, and within just the browser, you're able to manipulate your assembly. You can look at your part, you can look at the deformation, and these can be overlaid on multiple screens just in the browser. In the last couple of years, what we've done is we've also explored into virtual reality. So we have been able to convert the 3D data and give an experience to the user that he could just look at his design, critical designs, maybe at certain stages of his program, and he can look at the deformation much more in depth. Now, this gets streamed from the cloud to the device, and the device can connect and pull that data, very small packet, 50 MB, and you're pretty much interacting with it. This is the workflow that I mentioned earlier. This workflow is actually one of the most complicated ones. This takes about 3 months of work for an engineer, but with this workflow, the user can submit the simulation to OCI, grab the data, run the analytics platform, run the machine learning, classify the data, and even notify his designers as to which design he recommends. This, from about 3 months, we've been able to reduce it to less than 2 days. And I think this is one of the most efficient tool that we've created, where it's also transferable. You can send this data to an engineer, and he can execute with the same outcome. Now, just to give you an idea of the kind of templates that we build for our customers, this is Automotive Templates. What we mean by templates is a set of rules to extract the data. On the top, you see a NHTSA-regulated load cases on a typical car crash analysis. We have the roof crush, we have the SORB and side impact and MPDB. And at the bottom, what you see is the digital twin of that. And for all of these cases, we build templates, which means you just have to run your simulation and tell us what kind of load case are you running. And we automatically pick up all the responses, all the outputs, and we graph them for you. Now, why would we want to do that? So here's an example to illustrate the benefit of that. Here's a pedestrian protection. And what you see is a regulation where the regulation determines the zones on the hood where you need to provide protection. And that's about, for a single design, that's about 350 simulations. We call them a sweep. Now, for 350 simulations, it could probably take about 4 to 5 hours just to submit these simulations. And it takes about a day to post-process them. So what we have been able to do is to create a system where they can run this just within maybe one click. And we run those 350 simulations. Not only do we run them, we extract all the relevant data, and we prepare a table that would otherwise take a day for them to prepare. And here you can see that they get a data set that's colored to let them know the regions that are passing and to let them know the regions that is potentially that can be improved. So this is quite a bit of data extraction. Now look at the data size. For that 350 simulations, it's about 10 terabytes. And we condensed that down to 100 megabytes. And this is not any compression. This is just by extraction. And with that extraction and the passing of information, they're able to now look at this entire 350 simulation data sets in just about 15 minutes. This is another example. This is a very new regulation from NHTSA. What you see is typically a car-to-car impact simulation. The other car is represented by a barrier, which is by a honeycomb. And this regulation requires you to assess some standard deviations. And on the right-hand side, what you see is the extracted information where you predict or you tell them where the standard deviation is, and the color indicates the maximum deviation. Now, this extraction mechanism is very subjective to every single simulation engineer. But what we've done is we've worked with the subject matter expert, gathered those into a workflow, and the outcome is really repetitive. So you can easily distribute that across the company. Here again, you can see the benefit of the data size. It's about 2 terabytes to just about 10 megabytes. And today, the user simply runs these simulations, and he doesn't spend any time. He pretty much is able to look at this within just a few minutes. That's all I had to show to give you an idea.
Yeah, I think the great thing about Suri's service is that, as you showed, you can extract the data and reduce a large data set into 100 megabyte from 10 terabyte. So we talked about downloading data from cloud to on-prem and things like that. Softwares like this d3View can really help the movement to the cloud because you don't have to download everything. You extract what you need and delete all the data and just download 100 megabytes instead of 10 terabytes. So I think it's super valuable in the long run for cloud adoption.
Thanks, Tejas. And just a few remarks. I think we're excited about OCI because, I worked with Tejas back in Microsoft Azure days as well. But the bare metal performance is what our customers thrive for. And why do they want to do that? Now, if you look at an engineer, he comes into the office at about 9 o'clock in the morning, he looks at his previous data set, and he comes up with the next design, and he runs his simulation. Now, if your simulation is taking about 9 hours to run, he has no chance to look at that in the same day, right? And if your simulation is 6 to 7 hours, he has this time to look at it, make another change, and come back the next morning. So that is very, very critical for us. And that's where I think the OCI bare metal performance is critical, even to get us 1 design or 2 designs per day, and even beat the on-prem performance. And that's really what we like about OCI. And also the API. From our perspective, everything is behind the scenes. As soon as they click the simulation, we take care of everything at the back end. And OCI's interfaces incredibly well. And we can run DOE with about 500 to 1,000 simulations, and we've had very, very low fail rate when we talk to those instances.